So a big shout out to all the students who turned up to revision session on this Thursday. Well done, guys. This video is for you. Hopefully you're watching it either tonight or at some other point. Grab myself a nice cup of tea. What better way to spend an evening than to do some physics revision? So 6.4. We're going to start with foundation. I've given us the formula sheet anyway, but I don't think we're going to use it for the theme of space. So I'm going to just plonk that to the side just in case. So the first question, select the correct words to complete the cycle of a large mass star. So it starts with large mass, main sequence star. Then after when all the helium, when all the hydrogen starts getting used up because it fuses hydrogen to helium, it will expand. The core will get hotter, and then it will expand to a supergiant. So the outer layers are colder, but obviously it increases in size and it gets redder. And then once it'll start burning all the helium. Then, and once that helium's done, it will pretty much explode and become a supernova. At this point as well, all the heavy elements are getting made in the core because it's so hot. So elements like iron and copper and all that are getting made in there. Then it will supernova, boom, spit out all its guts into the universe, and then it'll just collapse in on itself and become either a neutron star or a black hole. In this case, I've picked neutron star because black hole wasn't up here. So a neutron star, not quite so dense as a black hole because there's still neutrons remaining. So it's crushed all the protons, crushed all the electrons, and basically you just got a clump of neutrons. So the whole mass of the star here is in a tiny space now, and we call that a neutron star. Okay, a lot of you don't need to know that much, obviously, but I thought I'd talk through it for 3 marks. And then explain in terms of forces why main sequence stars are stable. It's because the forces are balanced. You've got the gravitational force, the inward force, pulling all the gases in against the gas pressure, or we call it the radiation pressure, or you can say, well, don't use fusion because it's not in the mark scheme. So use gravitational force is the inward pull, and then the radiation pressure is the outward force. But they're balanced, so it's stable. So when the forces are balanced. I've also done on the bottom, just in case we have forgotten, the sequence of both stars. So if you've got a small star like our sun, it'll start off as a protostar, then the main sequence star, which is currently what we're living through now. It's really happy. Eventually all the hydrogen will get used up and it'll start burning helium, or fusing helium I should say, and then once that's done it becomes a white dwarf. So that's how our sequence for our star. And then a large star, as we talked about up here, it'll either become a black hole or a neutron star. It's a nice 6 marker, I thought. Our solar system consists of sun along with a variety of different other objects and planets, blah, blah, blah. Name these and describe some of the features and their relative positions. So basically, what I'm getting from this is they wanted to talk about the planets, different objects, which would be the asteroid belt and moons, and relative positions to the sun. So my very easy method just speeds up naming planets, although P was Pluto and not considered a planet anymore because of its orbit and just its mass. So I've said each colour represents pretty much a mark here. So there are 8 planets. Mercury, Venus, Earth and Mars are the rocky planets closest to our sun. So I've done that in order to the sun. Maybe I should have clarified that. Then the outer planets are much bigger and they're made of gas. They're gas giants. So we've got Jupiter, Saturn, Uranus and Neptune. And they're all the gas planets. For another mark then, between Mars and Jupiter, so between the rocky planets and the gassy planets, you get the asteroid belt, which contains rocky objects that never formed into planets. So because of the distance from the sun and the fact that they're heavy rocks, they never quite clumped together. So that's why they're sort of just orbiting around in the asteroid belt. Obviously gas a lot less dense, but that's why they're so big. Some of the inner planets have small number of moons, but the outer planets have got many moons because their mass is much greater, because they're much bigger planets. They attract more things that orbit them. Generally, the further away from the sun, the lower the temperature of the moons and planets. As I've talked about moons and planets, I've said generally there because you've got that odd anomaly where Mercury and Venus, well, Venus is actually hotter than Mercury, even though Mercury's closer to the sun, but that could be an incorrect result, so they're still researching that. But the orbit time around the sun increases the further from the sun, so a planet like Jupiter or Mars Jupiter is going to have a much longer journey time around the sun than Mars because of its orbit. 6 marks. Complete the following sentence. Solar system was formed by the collapse of a cloud of gas and dust is your answer to that. Okay, there's you just got to sort of remember that. The table shows some information. So generally, these questions are wrapped up with a table of information. And it's kind of your problem-solving skills then with your numeracy skills. It's going to get you the marks on these things. So describe how the temperature on a planet depends on the distance from the sun. Well, there's the mean distance from the sun. So you can see going from Mercury to Neptune, it increases. And then if we look at temperature, the mean temperature, like you said, that odd anomaly there, Venus, which is actually hotter than Mercury. But apart from that, they're all starting to cool down. So I've said the temperature decreases as the distance increases. Identify the planet that does not follow this trend. Well, they're alluding to this 430 and 465. So you're either going to say Venus or Mercury because they don't follow that trend. Now, if that was in Welsh, that would be called Pallas, but I'm guessing it's Pallas. Who knows? Is an asteroid found in the asteroid belt. Estimate its temperature. So, a bit of knowledge required here, where you should know that the asteroid belt lies between Mars and Jupiter, and the estimation of the temperature is going to be anywhere between -20 and -50 there. So that's why I've put -21 to -149, because it's not going to be -20, because that is. And then the same with the orbit time then. I've put 3 to 11 years because you've got the orbit time of 2 and 12 there. So it's going to be between that. And then it is suggested the greater mass of the planet, the more moons will orbit around it. Explain whether the data agrees with the suggestion. Well, when you look number of moons, the Earth has a mass of 1, because we always compare it to the Earth. And that's got 1 moon, but Mars has got less of a mass than the moon, but it's got 2 moons. So I'm going to disagree with that statement. It does not agree because Mars has less mass than the Earth, but it has more moons. So that's why I'm disagreeing with that.